Good morning, dear students. Today we are going to complete the properties of invertible operators. Let us recall what are the properties of invertible operators. The first one is if A are and B are invertible operators, then A and B are invertible. Okay. Also, AB inverse is equal to B inverse A inverse. Okay. Now the second property is if norm of A equal to Q and Q is less than 1, then I minus A is invertible. Okay. And I minus A whole inverse is equal to sigma 0 to infinity A raised to K. Now the last third property is let A be an invertible operator and B be such that norm of A minus B less than 1 by norm of A inverse. Then B is also invertible. Okay, this is what we have to prove. Okay, so we have to prove B is invertible. Okay, and the given condition is norm of A minus B is less than 1 by norm of A inverse. If you multiply this one, what we get? Norm of A inverse into norm of A minus B is less than 1. Okay. That is we have norm of AB is less than or equal to norm of A into norm of B. Okay, therefore norm of A inverse into A minus B is less than or equal to norm of A inverse into norm of A minus B, and this is strictly less than 1. That is norm of A inverse into A minus B is strictly less than 1. We have just to look at our second property. Second property is if A is norm of A equal to Q, Q is less than 1, then I minus A is invertible. That means here if you consider this as some C, norm of C is less than 1, this implies I minus C is invertible. That means I minus A inverse A minus B is invertible. Okay, now what is actually I minus A inverse A minus A inverse B, and this implies I minus A inverse A plus A inverse B is invertible. This implies I minus A inverse A is I plus A inverse B is invertible. Okay, and this implies A inverse B is invertible. What is our given conditions? A is invertible. Now you look at first property. A is invertible, B is invertible, then AB is also. Here A is invertible. Here we get A inverse B is invertible. So applying the first property, we get A into A inverse B is invertible. So if you apply associative property, A into A inverse B is invertible. That is I into B is invertible. That is B is invertible. Actually, this is what we have to prove. Okay, we have to prove B is also invertible. Okay, now we are moving to our last section and last theorem, and the statement of the theorem is the Banach open map theorem. Okay, Banach open map theorem. Now here we have only to complete the statement of the theorem only. No need of proof. Proof we will discuss in our next semester. Okay. So what about the statement of the theorem? You may ask question like state Banach open map theorem. Okay. So let X and Y be Banach spaces. Okay. And A from X to Y be a bounded linear operators which is one to one and on to. Okay. Then the formally defined linear inverse operator A inverse from Y to X is bounded. Okay, A inverse from Y to X is bounded. That means if A belongs to L of XY and A is 1 to 1, 1 to 1 and on to, then A inverse belongs to L of YX. This is our statement of Banach open map theorem. Okay.